Okay, hello everyone. I'm, as Jason said, Sue Grant. You can just go to full screen, I think, for the slide deck. That would be great. Okay, so what I'm going to present on today is the state of Canadian Pacific salmon. And we're going to talk about the profound changes we're seeing in salmon ecosystems and the responses of salmon to these changes. And what has emerged from looking at all these changes and as a key overarching theme of what we're seeing in our ecosystems and what we're seeing in our salmon is this climate change driver. And I think Francis Dwyer set us up very well for understanding where we're at and also where we're going from that perspective. So I'm going to talk about this background on what we're seeing, but also what we're thinking about in terms of next steps within Fisheries and Oceans Canada. So along with Bronwyn McDonald and myself, we lead DFO's State of the Salmon Program. And the goal of this program is to track and understand salmon trends, to better understand and adapt to the future. And we don't do this on our own. Our program is all about integration. So developing tools, developing processes that helps pull all our information together. So we work with our large DFO Marines, our freshwater programs, our stock assessment programs, as well as external groups that are all connected through our staff and also independently in terms of all this work being done on salmon and their ecosystems. We had our first State of the Salmon meeting in 2018, and the first part of this presentation, I'll be talking about what emerged from that first meeting. And as I mentioned, a key theme that emerged, pulling all our observations together, was climate change. And the theme of this talk is really about the need to look forward about where we're going and to really think about how we're managing salmon for this future, as opposed to looking back at the past, where we've been as a target for how we align and how we think about adaptation going forward. I think, again, Francis Dwyer really outlined clearly how the future of salmon is likely to look quite different under climate change. And so it's pretty important that we put that forward-looking hat on as we think about the future. So climate change is this big overarching driver of what we're seeing on our local salmon scales. And it isn't just increasing temperatures on the planet, it's also increases and changes in more extreme rainfall events, more periods of drought, more storms, so other climate factors that are playing out on this large global scale. And we're embedded in that global scale. And what's going on that planet-wide scale, we're also seeing on our local scales. So if we, DFO manages 5 species of salmon, and that includes sockeye, chinook, coho, chum, and pink. And these are anadromous salmon. It means they spawn in freshwater, spend part of their lives in freshwater, and then the latter part of their lives in the marine ecosystem. Our salmon move into freshwater, so they move into British Columbia and the Yukon Territory. They spawn, their eggs are deposited in gravel, and then their juveniles emerge from the gravel and they can spend up to 2 years rearing in freshwater before they migrate into the ocean for their latter part of their rearing. And in freshwater, we are seeing some large changes. So when we talked to staff and talked to people, and some of that came up in the questions just now as well, in terms of what we're seeing in freshwater and the changes we're seeing. They're pretty pronounced. Air temperatures over British Columbia are warming, and those warmer air temperatures are translating into warmer river temperatures. And where we're monitoring river temperatures, so the Fraser River is one example of that, we're frequently now, in recent years, almost consistently seeing temperatures in summer months that are exceeding 18 to 20 degrees Celsius. And for migrating salmon that migrate in these months, these temperatures are very stressful because they're falling outside the optimal temperature range of our salmon. So they're at the upper end of the temperature range that salmon comfortably operate in. So when you start operating in temperatures that are this warm for salmon, they start getting stressed. And this means that some of them might not survive to make it to their spawning grounds because of this additional stress of migrating upstream. And even if they do make it to their spawning grounds, it can have legacy effects on their offspring. So there's research that shows that this amount of stress on salmon can create poor quality offspring. So it can have this effect that lasts beyond the adults and the adults migrating. These temperatures are obviously not going to be consistent across all watersheds. So there is other factors that contribute to these temperatures. So if you have a good groundwater input that's inputting cool water, you have good riparian vegetation that's shading rivers and cooling them in the summer months, or if you've got a river downstream of a big lake that's buffering downstream river conditions, these are all factors that can moderate the effect of these warming air temperatures. We're also hearing that there are greater observations of drought conditions in summer months. So there's observations of these dewatering events that lead to stranding of eggs and stranding of juveniles in river systems, which leads to mortality of these younger life stages. This can also block passage of adult salmon into more prime spawning habitat, or just reduce the amount of spawning habitat available. In recent years now, we're seeing more forest fires. I know in recent years we're spending more time in the summer months with our windows and doors shut to block out smoke in the area from fires burning both within our province territory and also down south in the US as well. In 2017 and 2018 in British Columbia, we had 2 record back-to-back years of forest fire burns. And some of these fires burned right within watersheds that salmon are relying on for their freshwater life history. If we put forest fires together with other losses of forest canopies like pine beetles, and both fires and pine beetles are influenced by a number of factors, but climate change is playing a role in the expansion of, or increases in fires and the expansion of pine beetles. So if we have deforestation from these 2 climate influenced features, as well as human activities that include logging, agriculture, and other human development that's all contributing to deforestation, and you link that to more extreme precipitation events that are caused by climate change or amplified by climate change, you can see tipping points in some of our ecosystems where we're getting more sediments flowing off flowing out of the watersheds into our river systems and deteriorating the water quality in these systems. They can smother eggs, and they can also create blockages. So more extreme cases of this are landslides and things that are actually blocking fish passage to their spawning habitat or preventing juveniles from leaving their rearing grounds to migrate out of their systems. So in freshwater, we have this global overarching climate change driver, and some of what's going on in this, well, what is going on in this global scale is influencing what we're seeing locally. And a lot of these observations in recent years have been fairly concerning as we see water temperatures increasing and exceeding temperatures that are optimal for salmon. We're seeing more droughts, more floods, increasing sediment loads, landslides, and we're seeing synergies with these climate changes and habitat changes within freshwater. Not only is the freshwater ecosystem changing, but we're also seeing profound changes in the marine ecosystems that salmon use. So they move into the Northeast Pacific for their latter part of their lives. And in this ecosystem, we're also seeing large changes. This is a slide that Lori Whitecamp from NOAA provided to us recently in a presentation. And it was two figures that really concerned her. And this is from research from Chang et al., their UBC research team. And on the left plot, it's showing the warming content in the ocean, in the upper dozen meters of the ocean, increasing trend over time, sort of this linear increase. What really worried Lori wasn't just this increase in the surface waters, but the fact that the ocean's warming all the way down to the bottom. So this right-hand plot is what particularly concerned her, because you can see all the way down to the bottom, there's this increasing trend. The greenhouse gases that we are producing as humans, going into the atmosphere, trapping heat, and the planet's warming, 90% of that excess heat that's being created is being absorbed by the ocean. And the ocean is a huge mass of water. And once it absorbs this heat and all the way down to its deep water layers, it's not something it can just release the heat quickly. It will retain that heat for a long time. So even if you could magically snap your fingers and turn off this increasing temperature trend, the ocean is not going to release its warming anytime soon. Not only is the ocean warming in this linear way, but we're also seeing marine heat waves develop. And in 2013, a marine heat wave developed. It was 3 to 5 in the Northeast Pacific. It was 3 to 5 degrees Celsius above seasonal average temperatures, extending down 100 meters depth. So when you see a lot of red in these figures, that's above average temperatures. This really concerned oceanographers in 2013, so much so that they referred to it as the blob, just to emphasize how profound this was, or how important this was, this occurrence. And the challenge with this heat wave is it didn't go away. It's basically lasted on and off from 2013 to present. There's research that's coming out that links marine heat waves and the occurrence to global climate change. And global climate change predicts that these will increase in intensity, in frequency, and extent of occurrence going forward. We should expect to see more. So just running through, it moved around in the Northeast Pacific and up into the Bering Sea. so right next to Alaska there. Continued on in 2019. And right now, we still have a marine heat wave in the Northeast Pacific. And what's interesting about this figure is if you look along the equator, sort of this line at the bottom with the EQ next to it, that's the equator, you see a lot of cooling down there. And that's a La Nina. And La Ninas typically are linked to better salmon production. But what's interesting, and this is something Lori talked about to us as well, is that with these heat waves, now the predominant feature in the Northeast Pacific in recent years, this can override any positive influences potentially of the La Nina. So our understanding of how the past and past relationships link to current salmon production can change with these changes in the Northeast Pacific and the occurrence of these types of marine heat waves. The main pathway through which warmer oceans link to poorer salmon productivity is through changes in the base of the salmon food web, and these are zooplankton. Normally in our waters, we have these large, fat, juicy zooplankton species with big fat reserves, so you can see the fat reserves and the bigger zooplankton on the screen. And what happens during these warmer water years is smaller zooplankton species move in. They're less nutritious for salmon. They come up from California, start dominating the food web. And that's the key pathway that links to poorer salmon production. And we see more of these smaller zooplankton in these warmer years. Our scientists out at sea are also seeing some unusual fish. These are fish moving up from Mexico and South America into our waters. And one or two of these fish being picked up in cruises isn't a concern, but it's certainly a signal of changes that are to come. So as the ocean continues to warm, they anticipate distributional shifts amongst our fish species and changes in food webs should arise. So it's more of a just a take notice, things are changing. So similar, we have this global climate change overarching driver. We're seeing changes already in freshwater, and we're also seeing changes in the marine ecosystem. Increasingly warmer ocean trends all the way down to the bottom, more heat waves, shifts to less nutritious zooplankton species, and shifts in species distributions. So how is that affecting our salmon? This is a figure of commercial catch. It's one way we can put all the salmon data together all at once and get a feel for the broad trends amongst our 5 species of salmon. So it's catch in the millions on the y-axis. In the first 70 years of the time series, starting in 1925, catch was on average around 24 million, so quite high commercial catch. In recent decades, it's dropped down to half of that, down to 12 million. In the last 5 years, it's even lower at 4 million. And the last 2 years are pretty much lowest catches on record, starting in 1925, so extremely low catches. Fisheries are turned on and off, so catch is turned on and off and adjusts across our salmon populations to ensure that we have enough salmon reaching their spawning grounds to maintain the sustainability of these populations. The challenge we're facing right now is salmon productivity is changing, responding to some of these climate changes we're seeing and other factors as well. And no matter how much we're ratcheting down the fisheries, we're still seeing decreases in salmon numbers on the spawning grounds. So this is a figure from coming out of our first State of the Salmon meeting, pulling together all this information on salmon. This was a key table on just the trends. The most concerning species is Chinook, where declines are being observed throughout their range in British Columbia and the Yukon. And not only are they declining in numbers, but they're also decreasing in size. They're decreasing in age, and they're seeing decreases in the number of eggs produced per female. The other concerning thing about Chinook is this is not just a Canada trend. We're seeing it in the United States from Oregon, Washington, and up to Alaska. So it's a pretty broad trend. Sockeye and coho are also exhibiting declines, particularly in the central to northern components of the province of British Columbia. And all these three species, particularly in the southern components of British Columbia, we've run them through status processes within our wild salmon policy. And we have a number of these populations that are in red poor status zones. And similarly, COSEWIC, which is an independent group, have also assessed these as endangered, a number of these as endangered or threatened, meaning they're facing an imminent threat of extinction. So we're quite worried about a number of these populations. Even your pink, there are some declines for these in some parts of British Columbia. The two species that have generally been doing better are pink and chum. So they're generally doing better throughout their range, although in the last few years, chum have exhibited some poorer trends. There are exceptions to all of these broad generalizations, so there'll be exceptions. Some sockeye doing extremely well, some chum doing extremely poorly, but this is the general trend. Some of this information that we're starting to see in our salmon populations may provide some insight into traits of salmon that might make them better suited or better adapted to a changing climate. So those occupying more northern latitudes, those that are spending less time in freshwater like chum and pink, those with less fidelity to specific spawning grounds. So if they come in, they can move around a bit. They don't have to go to one specific spot. Like for sockeye, for example, are very precise in terms of where they hone and where they spawn. Those in less disturbed habitats, so away from perhaps forest fires, up in high altitudes, away from human development, there are examples of salmon populations doing better in those circumstances. We are going to be updating status and trends more quantitatively in the coming months through a series of State of the Salmon meetings. So that will just provide us with some updates in terms of that. So I come back to the theme of this talk is that we've got to stop managing salmon by looking in the rearview mirror. It's a theme that's kind of emerging with climate change. The future is going to look very different from the past. Slides have just glitched here. Tech support, I have, oh, there we go. Okay. So one thing we have to start, I propose, and others have proposed, when we're starting to look at this, is to think about where we're going. So we need to start thinking about what is the future going to look like. Francis Zwires presented future climate change projections, and he was showing things downscaled to the province of British Columbia. And it's all about taking those projections and converting them into some understanding of salmon vulnerabilities, so climate change vulnerability assessments. These assessments are within Canada nationally. We're looking at climate change vulnerability assessments within DFO and starting to roll them out for different species. And we have program leads looking at this on national and more local scales. And NOAA also is ahead of us converting these sort of generic climate change vulnerability assessments and designing them specifically for salmon. And so there's models we can follow. And I also know, I'll talk about that in a minute too, but I know that PKIC is also working in collaboration with Dr. Hyatt's group to implement parts of this for salmon. So combining the knowledge of PKIC with the knowledge of animals and ecosystems within DFO. There are 3 things we need to know for climate vulnerability assessments. We need to know exposure, which is over the next 50 years or 80 years, what are the climate projections and how do you downscale them into salmon, freshwater, and marine ecosystems? And that's part of what Dr. Zwires was showing this morning. We also need to know the sensitivity of the animals, the salmon populations. So what traits make them more or less vulnerable? So the time of year they're migrating as adults into their freshwater systems, their geographic range, what particular river systems they're using, what particular parts of the ocean they're using. And we also need to know adaptive capacity. So what's the flexibility in our animals to different populations to change their migration timing or change where they're spawning or where they're rearing in the ocean. Also, do the animals have an ability to modify their genetics to adapt to climate change? Now note that as the population sizes get smaller and smaller, we start losing that flexibility to hope for a lot of genetic adaptation. You really need a large number of fish with a lot of diversity in their genetic code to get to the place where you can narrow down or where you might have the capacity to adapt genetically. Within DFO, I just want to highlight some of the work that we're doing. We have a big ocean program in Sydney at the Ocean Sciences Centre. This is where a lot of ocean research goes on. So just find research in the ocean, not just ocean temperatures, but dissolved oxygen, pH, ocean circulation, and the base of the food web, phytoplankton, zooplankton, the plants and animals that form the base of our fish food webs. And in the Institute of Ocean Sciences, there's work being done to downscale global climate change models to regional scales relevant to fish. So that's work that's being initiated there to support this type of work. The Pacific Biological Station in Nanaimo is where a lot of our science is occurring. Our research on marine research out in the ocean with juvenile salmon. So there's a number of research programs there with Dr. King and Chris Neville and others. This is where Kim Hyatt and other researchers are based, starting to look at downscaling and climate change from a freshwater perspective, and tons of other people in there working on things. We have a lot of freshwater research in our Cultus Lake laboratory. And also out of Simon Fraser. They're looking at climate change in our lake ecosystems and also scientists hired to help other work like eWatch. Well, eWatch isn't based, they're based out of Simon Fraser, but they're part of this group. My slides are not projecting again. There's also the, until this moves forward, I'm kind of stuck. There we go. Slide here.
Hey, Sue, I think we just have a little bit of laggy.
Here. We have of.
Sorry, Sue, it's Jason here. Can you hear me?
Yeah.
We just have a bit of laggy internet, I think, on your side. That's okay. What it looks like from here. So
yeah, because I'm way forward right now.
Yeah, we can see the slides moving on this end, I think. So I think if you just carry on, the magic of the internet will catch itself up. So we'll see how it goes. But we're watching it on this end for you.
She could turn off her camera too.
Oh, and Derek says if you could turn off your camera, that might save some of the.
Can you put it back? Okay. Could you put it back? back to the slide with all the research.
Do you know what slide number or what's the picture look like on that slide?
It's the one with all the images of PBS, iOS, PKIC, not PKIC.
Move it forward one. Yeah.
Yeah, I think it's forward. Yeah, just get all those images on. That would be awesome.
Okay. Yeah, just advance it so we get all 4 images up there. And is that where you want to be, Sue?
Perfect. Yes.
Okay.
Thanks, guys.
And so we've got, if you could wrap up in 3 or 4 minutes, I think that would be ideal.
Okay.
Great, thank you.
We also have foundational offices throughout BC and the Yukon, our area offices, and they form that long-term consistent monitoring of our salmon populations. And in order to do research, that work is critical, obviously linking in with First Nation communities and other groups. And we also have teams working out of our regional headquarters. So we have myself and Bronwyn working out of headquarters, but also other programs within that that space as well. All that forward thinking about where we're going is critical to place it into work that's ongoing, to think about what we need to do now. We have a national ecosystem approach to stock assessment where we're starting to think about environmental information that we put into our stock assessments, and some of that forward thinking, the climate vulnerability assessments and climate projections going forward is going to be needed in that broader context. How we think about recovery and rebuilding planning is also going to be critical with that forward-looking perspective, because where we're going is very different from the past, and we've got to be very careful about where we invest our energy now so that it is actually set up to prepare us to adapt to the future. And what are the targets? What are realistic to plan for from a recovery perspective? And all that climate change vulnerability stuff is important to seed this type of thinking. Also, there's things called management strategy evaluations and ecosystem modeling. It's a lot of different modeling approaches that look at these future projections and place it in the context of decisions we need to make. So what kind of habitat is the best approach to take from a habitat restoration perspective? What hatcheries, what fisheries, all of that needs to be placed, or already is placed, into these management strategy evaluation modeling contexts, but must consider that forward-looking climate change consideration. DFO is thinking or recognizing that we've seen these large changes in our salmon ecosystems and in our salmon, and we're seeing concerning trends. So they're initiating, the department's initiating a Pacific salmon strategy, and it's all about collaboration. So working together, breaking down silos, and starting to come up with a common vision and direction in terms of where we need to go. And I'll close on this. It's about creating a shared vision and alignment. So what's critical is that we all get on the same page, and I've heard that mentioned throughout this talk, previous talks, that we have to think about, okay, I'll start with, we're all coming at this from the same place. We all deeply care about salmon, their ecosystems, and people. And we all want the best possible outcomes for salmon and people. So the key is that we all align and we have a shared vision, and we talk about this and we figure out, and this is why it's excellent that the PSF is starting this dialogue here today, to get alignment so that we can all start pulling in the same direction. And we have to think about what our strengths are, what our niches are, to support the science and the adaptations we're going to need under climate change to avoid redundancies and find synergies. And that's going to involve a lot of dialogue and a lot of working together. And hopefully DFO's salmon strategy will help with that, as well as initiatives by other groups. And I will just say a lot of this is published, and we've done work with the FAO to start to think about climate change from DFO, both a publication we've done recently, as well as Jackie King and Ian Perry on the marine ecosystem and their State of the Salmon updates in our reports. And tons of people contribute to everything we do within the department and also outside of the department, including First Nations, the Pacific Salmon Foundation and the Pacific Salmon Commission and others. So this presentation was really an amalgamation of, hopefully you'll see yourself in the perspectives provided here. The only last thing I wanted to end on, because it came out when I was thinking of Dr. Zweier's talk, was the need to mitigate greenhouse gas production. We may not have control of that, but one thing we should be worried about is adaptation still needs to be prefaced on mitigation. And where we can, I think we have an obligation to do our best there to help influence mitigation. Okay, thanks, Jason.
Yep, and thanks, Susan. It's Marcel again. Great presentation. I always enjoy looking at your presentation. So we have a couple of Slido questions for you, Sue, and we've got about, I don't know, 5, 6, maybe 7 minutes. So let's get rocking. First of all, Brian Riddle says you hands down get the best prize for the rear view mirror image. Very good. He liked that.
Okay.
So
Cool.
And the second is, if looking back is no longer a way to predict the future, then what is the single most important thing that needs to change moving forward?
Okay, that's a good question. I think that's one for all of us to think about. It's not that the past help because we definitely need those long time series and those relationships to help think about the future. I mean, I don't know. This question's kind of a big open-ended one. The single most important one is the last slide I had. We have to all start, like, I can't answer that. We all have to answer that, and we have to answer it together and with alignment so that we're all pointing in the same direction and pulling in the same direction really fast.
Thank you, Sue. That's helpful. And so that's a message for everybody here. Thank you. Rupert Gale asks, you state that we need to look forward, not backwards, with respect to salmon and climate change, then went on to describe dire impacts on salmon populations. Currently, we take heroic measures to keep some populations on life support, but should we instead triage to focus on populations more likely to succeed?
I think I would go back. I could answer that from my own opinion. I think we're going to have to take a look at that carefully in terms of where to prioritize. But I don't want to answer that conclusively because I think we all have to come together and answer that question. I think that's a really tough one, and we do have to look at finite resources and what we need to do and prioritize. And it's also not just about salmon, right? It's what we're doing to protect and preserve is for all the animals that are and plants and the life support system that we rely on. So it's also taking a step back. And we can triage salmon to some extent, maybe, but we all have to talk about that. But we also have to think about what we're trying to do writ large. So I think these collaborations have to extend beyond just salmon ecosystems. It's got to go into bird people who care about, well, we care about birds too, but we need the bird experts. We need the amphibian experts, everyone coming together.
Thanks, Sue. I think the final question I have for you then is from Stephanie Peacock. You mentioned that salmon with more northern distributions are doing better. Is because temperature thresholds in survival/productivity haven't been reached in the north? Or are there biological traits of these northern populations like life history, adaptive capacity, that make them more resilient?
I think it would, well, there'd be a bunch of things. I don't think exclusively. I think the temperature piece would be an important one. You might have more pristine habitats up there as well, less human activity. compared to if you look at the mouth of the Fraser and parts of British Columbia, which are have much more development and human activity. I'm not sure if it's specific to life history and adaptive capacity. It's probably more related to the external drivers, but I think, again, that's part of a bigger conversation. I think it's work ongoing.
Okay, and the final question, one popped up, Sue, for you, and then we're going to break for 15 minutes, is from Mike Meanier. Washington State has a 20-year-old model of salmon recovery built from the watershed level up, collaboratively with all players involved. Are you looking at a new model for how we all work together from watershed up?
I think that's something that a lot of different, like me personally, I think there's a lot of people thinking about putting things together in different. It's going to take a lot of different tools, a lot of different modeling approaches, and a lot of different things. So not one model, but many. But I can't comment specifically on this 20-year model. Yeah, I'll just say that there's a lot of different approaches that we're going to have to work on collectively.